the concepts certainly are the same. So I'm going to do this one example here. I'm just going to make this a smidge bigger so that you can see it. You've got it on your sheet. I hope you guys all have it. Keith and Noah, did you guys get the sheet? Yeah? Brian, you got it out there? Awesome. Okay. Okay, so we've got, I'm going to do two of these type of ones. We have two masses are moving before a collision as shown. We have a 3 kilogram mass moving at 4 meters per second north and a 2 kilogram mass moving at 5 meters per second at north 45 degrees west. Now, obviously, in curling, the stones would be identical sizes, or at least very, very close. But this is sort of a different situation. After the collision, mass B is observed to be moving at 3.5 meters per second at north 20 east. Find the velocity of mass A. So the first thing we're going to do is draw. We want to find the final velocity of mass A after the collision. Okay, so let's start with drawing a picture. And I'm going to get my notes out because these can be pretty challenging, and I want to make sure I do it right. Okay, so initially, now I'm going to draw them sort of side by side just to save some space, but we've got one colliding. So we've got A. Oh, let me do this before we get too much further. Okay, so A is moving straight north. I'm just going to make it a smidge easier. And B is moving at north 45 west. Like this. Now, normally I put in the amounts right there, but remember, these are actual momentum vectors. Okay? So let's deal with the initial first of all, and then maybe we'll, well, you know what? Let me do this. You guys probably are going to hate that I did this. Which way are A and B going to go after? Away. What do you mean by away? A is going to go like that way, kind of thing, isn't it? And B is going to go straight north? Kind of like that, I think, right? You think it's straight north? It probably is possible, but unlikely, right? Okay, so holy moly. I should have looked at this ahead of time here. Give me 30 seconds here. So, we know that initial momentum is equal to final momentum, right? And I guess you could really say that the initial momentum is momentum A plus momentum B, which is equal to momentum A prime plus momentum B prime, right? Remember, again, the prime refers to after the collision. So we are asked to find the velocity of mass A. Before I can find the velocity of mass A, I have to find the final momentum of mass A. So final momentum of A plus the final momentum of B is going to equal PI. Right? If PI is PF, then, oh, I use primes here and here I use Fs, right? Is that okay? I know I should. Which one do you want me to use? Primes? Okay. Okay. Jump and change these? Yeah, I should have done that. It's okay, Nate. Yeah, let's just do this again. It's okay. It's okay. So that's going to be PA prime plus PB prime is equal to the final, which is equal to the initial. I threw an extra little step in there. Oh. Now we'll leave it like that. I get it's confusing stuff. Yeah, because the final and the initial are the same, right? PA prime then is going to be the initial minus PB prime, right? All I do is take that PB prime to the other side, right? So I am, in effect, here doing what? I'm doing vector subtraction, right? because PA prime is a vector, so I'm going to be doing vector subtraction. So I've got to break the initial momentum down into components, and then I'm going to subtract the components of PB prime. Right? Everybody with me? I want to make sure everyone's with me before I get too far into this here, including myself. Still debating whether I'm with you or not. Let's just come up with the momentum to begin with, right? So what is momentum of A previously at the start? A is 3 kilograms moving at 4, so it's going to be 3 times 4, 12, right? And it's going north. I'll put it in brackets to imply the direction because sometimes that might get confused with newtons. I'm not going to bother with my kilogram meters per second in there. That's just going to clutter stuff up, right? We all know what the units are. That's initial. PA initial is 2 times 5. PB, peanut butter. $10. Nate, try not to get distracted. And that's going to be north 45 west. Okay. After, what do I know after? I know that mass B is moving at 3.5, right? Okay, so all I did there was what? Write down the actual momentums. Figure out the actual momentums. Okay. Got it? Good? Okay, so let's go back to this setup that we had here. So I need to know PA prime, which is what I'm trying to solve for. That's the missing space down there, right? Is PI minus PB prime. The initial one is, so I have to add A and B together, right? This PI is A and B together. So let's do that first. We got to have an X for A, right? X component. Momentum of mass A, X component. A is moving straight north, so PAX is actually 0. X component of the vector. Momentum of mass A, the Y component, it's all Y, it's all north, so it's in fact 12. How come I don't have that here? 12. Yep, okay, just making sure. Momentum of Bx is what? Ten. It's going to be sine of north 45 west, right? North 45 west. So the x's, they're both going to be the same, right? Sine and cos, which works out convenient. It's 10. Thank you. I don't have the whole thing in front of me here. 10 sine 45. It's probably going to be cos, but it doesn't matter because it's 45. They're going to be the same number, right? I don't know, because I don't actually have it here. I did it a different way on my notes, which is, I'm really in trouble when I do that. Help me out here, gang. I don't know, man. I'm just winging it here. I clearly should have sat down last night instead of watching the Raptors game and learned how to do this again. Help me out, Nate. 10 sine 45. 10 sine 45. 7 something, I think, right? 7.07. Now that is, so the x is going to be negative, right? Because it's moving left. X is negative. Y is positive. Okay, so what's my total momentum before? My total momentum before my px is going to be minus 7.07. And my py is going to be 7.07. Now, do I have to? Oh, plus 12. Oh, my God. Thanks, Nate. Glad you're here, man. I was thinking about the next step already. Do I have to put those together, like do Pythagoras and put them together and come up with a degree? Well, you should, but what are you going to end up doing in the next step after that? You're gonna break them back into this, right? Because what are we going to do? Right? We've got initial momentum minus PB prime here, right? So I'm going to have to convert it back to components to do that. So in other words, there's no point in doing that right now. I think that's what I did on my original set of notes. Okay, so let's just leave like that. Now we got to find the components of PB prime. That page is going to be really big here. PB prime. PB prime X and PB prime Y. This takes me back to university and all the crazy math professors. And I remember sitting there thinking, I don't know what they're talking about. And thinking, yeah, that's what the kids think right now with me. This? No, not this necessarily. I never took any chemistry or biology in university. No, I don't think so. Okay, so I got to get my B here. PB prime is 7 north 20 east, right? 7 north 20 east. So that's going to be north 20 east. Ooh, 7. So there's my X and there's my Y. So PB prime X is going to be 7 opposite sine 20, positive. And PBY is going to be 7 cos 20. Help me out. Am I doing okay? Have I got everyone? Yeah? It's okay. Sometimes you just got to sort of look at the whole thing when you're all done to get it, right? So just stay with me. 7 sine 20 and 7 cos 20. Thank you. 6.6. And they are both positive, right, Sam? Up and to the right. Okay. So I think we have all the pieces that we need. So now we go back to this. This is sort of the main structure here, right? Like that's where we got to, that's our template. PA prime is equal to PI minus PB. So I'm going to take my PI that I figured out, and I didn't convert back, and I'm going to subtract, vector subtraction, I'm going to subtract PB prime. PI was these numbers here, right? This is the initial X, total X, and this is the initial Y. And I'm going to subtract. Oh, I wish this thing was over here. I hate that it's over there. Okay. So I'm going to take this minus 7.07 and I'm going to subtract the 2.4, right? And that is my PA prime X. is going to be minus 7.07 subtract 2.4. Do you know why it's vector subtraction? Back to here, Nate. PA prime is equal to PI minus PB, right? Okay. Remember those good old days when you didn't want to show your work? That's why I forced you to do it. So that's going to be minus 9.47. And P A prime Y is going to be 19.07 minus 6.6. 19.07. Help me out there. I got slightly different numbers here. That's it. Okay, so those are my components of A after the collision. Now do I put them back together? Yes, because I want to know the final velocity, so I got to find the final momentum. So PA prime squared is going to be 9.7 squared plus 12.47 squared. It is a little redonkulous, isn't it? You're sure not going to do this out at the Dauphin Curling Club, are you? For taking a shot. Yeah. Yeah. I'm not even going to bother with the squared. Oh, what did I just do? What did I just do? We have a lot of fun in here. I'm just going to get, you guys can do that math. I'm going to get 15.7. Am I right, Sam? Yeah. Yay, I got the number that I got on my sheet. Took a little different route to get there, but. So the final momentum of mass A is 15.7 kilogram meters per second, but the question asked for the what? The velocity. So now we go back to mass of A was 3. So it's 15.7 divided by 3. 5.22 meters per second. That is ugly, isn't it? Am I done? You all know when I say, are you done, and you're not done, right? What's the last thing I got to do? Yeah. But that's easy, the direction, right? Okay, so we got minus 9.47. So we already know that A is going, we'll go way back to the top here. We already know that A is going left and up, right? So it's going to be negative X, positive Y. So basically, I got to find this angle right in here, right? So it's going to be west of north, yeah, north something west. So the X was minus 9.07. You want to go the west of north. So this is 12.47. This is 9.47. So there's my angle in there. Inverse tan, 9.47 over 12.47. By the way, you know what would be really helpful on the test if you guys would do that for me? If you could just all get it right, then it's a whole lot easier to mark. Could you do that for me?
Well, I don't know. Can you teach us to get it all right?
Good point. Either that or get it completely wrong. I'll leave it blank. One of those two things, if you don't mind. Kidding, I'm kidding. I get, that sounds about right. North 37 west. How much do you think I should allot? How many marks should something like that be worth? Come on. Is my reputation that bad? 1, 2, 3. Probably 1 for that. That's a, right? No, I should give you more for that. 1 for that. Is it 9? And I'll just give you 1 for all of those, right? They're all the same. How much is all that, Mustafa? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many questions will I put on the test like this? 1 and only 1. Really? I'm going to make you do that twice? Not on a test. No way. Show your work. You're bound to get something, right? I agree. Long and crazy and stupid. Oh, I agree. It's completely stupid. Do you want to give that one a whirl on your own? I'm not so sure I want to do it. All right, okay, I'll do it. Yeah, we should. Okay, you know what? I got one. I think. Yeah, let's do this one. Excellent. Here's what I'll do for this one. How about I do this? I'll do this one and I'll just post it for you. Is that okay? And that way I can write it out nice and neat and proper. I'll do that for you because I'm such a swell guy. You're welcome. Now, I know. This is what the accident reconstructionist basically does, right? We got 2 cars. They just happen to both be 1,000 kilograms each. Obviously, you don't have the animation on your paper, but you do have the question, right? Okay. So they're meeting at an intersection. They're about to collide. Car B, blue, is traveling at 20 meters per second east. Car R, red, is traveling at 10 meters per second north. After the crash together, what is their combined velocity after the collision? True or false? Absolutely. It's always true. Okay, so initially, I'm probably going to need way more room here. Is that true? Gotta do this again. Okay, so the momentum of, they didn't use A and B, did they?
Red and blue. R and B.
Now I'll do it right.